Namaskar and good morning all attending this 7th national webinar on mechanism, causes and measures of landslide hazards with examples from different areas arranged by NATMO from Department of Science and Technology, Government of India. Today's topic is very much related to our subject of earth science, and I know all participants are eagerly waiting for the discussion. Landslide may be roughly described as the movement downslope of a mass of rock, debris, earth or soil. Gravity is the primary driving force for a landslide to occur, whereas heavy rainfall, erosion, poor construction practices, earthquake, volcanic eruption may be the cause to trigger landslide. We will have our knowledge in this regard from our learned guest speaker. But before that, this webinar will be inaugurated with a welcome address by Director NATMO, Dr. Taputi Banerjee. Please, Madam.
Good morning, all of you present over here in this webinar. First of all, I welcome all the members of NATMO and as well as the members, the participants outside this organization who are present over here in this webinar. I heartily welcome our guest speaker, Professor SUNIL Kumar De from Department of Geography, Northeastern Hill University, popularly known as NEHU, Shillong. I feel Professor De needs no special introduction. His specialization in geomorphology has made him renowned not only national arena, but as well as in the international arena. Not only he is specialized or renowned by his work, he is also one of the well-wishers of NATMO, and everybody, I think, who knows him, they know his helpful nature out of his this academic line. And everybody is well known for his nature, friendly and helpful nature. Friends, today NATMO is celebrating 75 years of independence. Like other organizations of government working under Government of India. As a part of that, NATMO has arranged 75 events, and today's webinar is 7th in this series. And today's theme of lecture is landslide hazard, its mechanism, causes, and measures. And all we know, landslide in recent past, especially in the hilly regions of India, making our life highly disturbed through the huge loss of life, property, as well as livelihood. Even some of the landslide events, we usually do not come to know, do not have the wide coverage. The recent event of Uttarkashi in Uttarakhand on 7th of June 2021 blocked the Gangotri National Highway after a massive landslide in that area. And even the June 12th, 2021, there was a landslide triggered at the Maldepta village, and the local people were of the view that the illegal construction of roads in the high seismic zone is the main cause. So natural landslide, sometimes man-made activities are imposed on this natural landslide. So today we will listen from Professor De, Sunil Kumar De, about the mechanism and of landslide, their causes and impacts. I request Srimati Madhurima to welcome our guest speaker for his deliberation.
Thank you, Madam, for your warm welcome address. Now we have come to the time to hear from our learned guest speaker, Professor Dr. Sunil Kumar De, from Department of Geography of Northeastern Hill University, Shillong. Dr. Professor De is a MSc and PhD from Calcutta University. His major field of interest are geomorphological hazards, especially landslides and soil erosion, fluvial dynamics, and human impact on environment. He has published 68 research papers, edited and co-authored many books. He has taught as a visiting professor in University of Mexico, Abu Dhabi, and Indonesia. Shanxi Institute of Geological Survey, China, has honored him as a distinguished expert. We are eagerly waiting to hear you, sir.
Thank you very much, Ms. Madhurima. First of all, I would like to thank the director, Dr. Taputi Banerjee, to take up this mission to organize different types of lectures on different branches of geography, and from which this NATMO can get some feedback for preparing different types of this maps and database also. I would also like to thank Madhuchanda Sen, who eventually my classmate, for contacting me regarding this. And I told that I've been working on landslide for a long time, so I can speak on this issue. So I thank, along with I thank all my friends and colleagues from NATMO and those who are participating, my research scholars, students in this webinar. Now, I am directly coming to this topic.
Yes, sir. Yes,
Okay.
sir.
Okay, so mechanism causes measures of landslide. And I will cite examples from Darjeeling, Himalaya, as well as from Tripura, because in these two fields I have been working since 1993. Now, see this. Now, this presentation is based on geomorphological studies, mainly. It is not purely geological or engineering aspects. And the whole presentation I have divided into this way. This usually analyze the landslide in the following aspects in geomorphology. Number one, it is mechanism. Number two, what are the causes? And among these causes, we have the two causes mainly. One is triggering factors and number B is the inherent causes. And I will cite examples from Darjeeling in this case. Number three, scientific investigation, what we do, what is our responsibility in this case. Number A, it is database of geotechnical investigation we need to prepare. Number B, we need to prepare hazard and susceptibility analysis, but usually we do on a large scale basis, but this small scale as toposheet size basis in some cases for our scientific aspect. But for this, for planning purpose, we need to prepare this large scale hazard or susceptibility analysis map. After that, there is a risk zonation. I will cite examples from Tripura. Last one is planning for protective measures. So by this way, I have divided my whole presentation. First one is mechanism. Now, if we see, there are different types of landslides. One is fall, mainly fall, slide, and flow. These are the three main. Apart from that, we have topples and lateral spreads, but these are not very common in all the areas. While the slope is very high and this water content is very less in most of the cases, this falling takes place, and then slides along the slope when the slope is about 30 to 40 to 45 degrees, along with some amount of water are there. They produce the slides and flows. It is composed of water mainly, and this classification was proposed by Vance in 1978. Now, this mechanism, for mechanism, we need to understand the factors of safety. Firstly, what are the resisting forces? It means that if a slope is normal and the slope is formed naturally, whatever be the material, this composed material, it doesn't matter. But if it is formed naturally, the resistance power of the slope remains intact. But when it is disturbed by anything, maybe we are cutting the roads for constructing, we are cutting the slope for constructing roads, this may be, the resistance power is lost. Then if there is a high amount of this rainfall, then this earthquake, all these things, resistance is lost. So that is why resistance power means if I sit on this building and if the building is concreted, it means that building has the carrying capacity of all the loads. This is called resistance. And driving force are the external forces. For example, rainfall, when heavy and concentrated rainfall is taking place for a few days, then the water is percolating. In some cases, if the amount of rainfall intensity is very high, for example, 3-4 hours of rainfall taking place, and the intensity is very high, in that case, water gets hardly any time to percolate downside. So in that case, surface runoff takes place. This is also driving force. There are several other driving forces. So if we go to the field, if we collect the data or if we measure through instrument, there are different instruments now, to assess the resisting forces of the slope. And apart from that, if we collect the data related to earthquake, related to human activities, related to rainfall amount, these are the driving forces. So when the ratio is less than 1, means resistance force is very less. In that case, slope is a condition to fail. If it is more than 1, then slope, there is hardly any problem of the slope. Now, if it is equal to 1, it may fail or may not fail depending on the extra driving forces in that area. Now, as a layman, if I go to this hilly region, how can we find that this slope is stable or unstable? We don't have any instrument. Say, as a layman, if we go to the field and if we see that any tree, it is not grown up vertically, it is leaned towards the valley, the downside slope, then we can understand as a layman that this slope is vulnerable. Anytime anything can happen. If huge amount of rainfall takes place or any type of even 5.0 or more this magnitude earthquake takes place, the slope may fail. So this is the case. This is this mechanism of the slope failure. Whatever be the factors or causes responsible for this, if the resistance power does not go below 1, then it is hardly possible to occur any type of landslide. Just Madam was speaking about this Devoprayag. You have seen, I think, this video. Is it visible, the screen?
Yes, it's visible.
Yes, sir. It's visible.
Yeah, just see, the road was constructed along this vertical slope, almost 70-80 degree slope. And see, the whole slope will come down. This is the latest photograph of Devoprayag region. Now, for example, you are crossing the road and this falling is taking place. These materials are going down the river. And just imagine how much amount of sediment will be supplied to the river. And naturally, the whole slope is modulated due to this landslide event. Now, as a layman, this is a diagram. The rainwater is percolating through this porous layer. Then porous layer becomes slippery and the upper layer becomes burdened. Sometimes it fails and comes down the river. This is a layman diagram, of course, because usually when the rainwater percolates, but if the intensity is more, it hardly finds any time. Now, next one, I'll come to these causes. Now, we have discussed about the mechanism why landslide takes place. Number 1 are the triggering factors. From Darjeeling, which I'll cite example. Now, see, triggering factors usually, before the acceptance of this anthropogenic activity, rainfall and earthquake were the triggering factors. But nowadays, even in 2016, International Geological Union, which was held in Durban, they have approved, they have given the seal that yes, Anthropocene is an era, and anthropogenic activities is one of the major causes of occurring landslide nowadays. And as a geographer, we know very well the magnitude of changes due to human activities is much more higher than any type of natural activity. So just imagine regular 6 million tons of sediments are being collected from the Earth's and subsurface layers. Many of the microgeomorphic topographies have been changed and are being changed. If you come to Meghalaya, if you go in the southern part, they do not follow, during this corporatization era, they do not follow any science. They are collecting the limestones, they are dumping the waste materials there, and they are taking out this limestone to the cement factories. So naturally, we can understand that human activities is one of the major causes. Now, I will cite examples so that we can understand this. This is this Darjeeling Himalaya. If we consider these high-rise buildings have been constructed, if you go to Darjeeling, I have been going there since 1993. I do not enjoy nowadays because the city is full of skyscrapers, jungle of buildings, and to construct this, we need to cut the vegetation cover. Now the slope has been barren. Number two, we had to construct road to reach that area. And when the slope becomes barren and this raindrop falls on the surface, rain splash, erosion takes place, the soils become clayey or wet, and this slope sometimes fails, and along with this earthquake. So rainfall, earthquake, and human activity. This is a pictorial presentation of this triggering factors. If we consider Darjeeling Himalaya, this both sides, the amount of rainfall is very high. But if we see the landslide distribution map I will show afterwards, the number of landslides are high in the middle part of this whole Darjeeling Himalaya. Why it is so? Because the rainwater is coming through these valleys, and this is the downside valley, this is Balasan River, this is Mahananda River. So all these landslides are occurring along these river valleys. So and moreover, these parts are covered with, in most of the cases, these parts are covered with dense vegetation. So what is the role of vegetation? When raindrops fall on the surface, the velocity reduces because raindrops firstly is obstructed by the canopies of the trees, tree canopies, and the velocity reduces. So amount of erosion, amount of sliding phenomena is this reduced, and these areas are highly settled. Here it is this Darjeeling town, here it is Karshiang town, here it is Mirik town, here it is Kalimpong town. So all these areas are highly settled nowadays. So naturally vegetation cover has gone. Now this is the spatial distribution. This is Darjeeling town. This is year-wise distribution, This is temporal distribution. This is Darjeeling police station, Balasan River Basin, Karshiang subdivision, and Darjeeling Himalaya as a whole. See, the number of landslide are the highest in the middle part. Now, if we see this, these are the major landslide events. Up to 2015, we have recorded, and in many places, these earthquake events, you see, Nepal earthquake, it was in 1934, it was in 1934. This was Bihar Nepal earthquake, it is known as. And most of the cases are this heavy rainfall and gravitational pull, heavy rainfall and gravitational pull. And in 2011, another Mongon earthquake, it took place. So before that, in 1950 somewhere, there was a minor earthquake, of course, because the epicenter was in different positions. So earthquake and rainfall both used to play this role in occurring landslide in Darjeeling Himalayas, and nowadays these human activities. Now, if I come to this, many of the participants here may have seen these photographs, but I need to, for the sake of this causes, I need to discuss it again. Say there are an analysis of frequency of landslides in different parts of Darjeeling Himalaya since 1899 reveals that the most common occurrence of landslides are found in this along the springs to construct the roads across these springs, at illegal coal mining sites, tea gardens, and urban agglomeration. So these are the 4 types of human activities are mostly important in Darjeeling Himalaya. So this is Pagla Joda area. Every year it is constructed the road and it subsides again. It will construct nowadays after 2011. The whole hill slope has been cut because the road was totally destroyed. Now the road is taken the bend through the hill slope. The whole slope from the top to bottom has been cut to divert the road. And up to 2014, it was on trial run. So you can understand and see the materials are coming from the upside. This the rainwater, it is percolating through the porous layers and it is coming from this. And Professor M.K. Bandyopadhyay is standing here. Just see if that type of rockfall starts or slide starts, where you will go. But there is hardly any chance because it's totally dry period. So there is hardly any water molecule within the surface. And by this way, every year since 1968, every year this type of retention wall is constructed. And this was the road earlier time. So by this way, every year they are constructing these retention walls and the road is being diverted. So this is one cause. This is the present road condition now. Coal mining. British geologist E.R. Mallet in 1899, he found that there is a thick coal seam in Darjeeling Himalaya, Tindaria Belt. And when people came to know this fact, they started to mine this coal from this area. He is Dr. Sudip Bhattacharya from North Bengal University. Now, in the latter half of the 1970s, in Jadavpur University, Professor Aurobindo Ghosh, he collected this sample and tested in their laboratory, and he found that these are anthracitic coals. It means that very high quantity of carbon within this coal. And this is the coal belt seam from Tindoria to Bagrakot in Darjeeling, Himalaya. So this is a thick coal seam. And although government of India has issued the notice in 1960s that coal mining is banned, but who is listening this one? It is the source of the bread and butter of many of the people of this region. So now they collect this coal in the night time, and this female population of that area, family members, they carry in the early morning in the Bagrakot market and they buy their food stuff with this one. So by this way they carry this material. So this is very old photograph taken in 1993. So just imagine. Now this is the Trinidad cricket colony landslide, and you see these are the coal mines and they have collected these coals unscientifically without filling sand, water, anything. So it is started in this 1993, but till today it is continuing. Tea garden, it is usually it usually stabilizes the slope. But after 1991, poor maintenance of the tea gardens are causing different types of problem. You see, there are food tracks along this one. This area has been barren. If we see the statistics of tea gardens in Darjeeling, Himalaya, it was commercially started in 1861. One British fellow went to China in 1856, and he had seen that tea bushes are there and they are very common drink in China. So he collected some bush and planted, came back to Darjeeling and planted in Darjeeling, Himalaya. He had found that it is very good quality. So after that, from 1861, it was started in commercial basis. And the number of tea gardens were the highest in 1891, 177, although the area of land was not so high. But the area of the land was highest in 1961, although the number has reduced because many of the tea gardens have been merged. And sorry, in 1961, it is 27,000 hectares, 28,000 hectares almost of land. After that, in 1991, usually the chairman of this Tea Planters Association used to be a British people because they started this one. After that, Indians took over. And since 1991, different types of social and political problems started, and tea gardens started to deteriorate. And you see the number and area both have been reduced up to 2011 because 2021 data till now we didn't get, it is not published. So this area has been reduced. So Darjeeling tea is losing its international fame. And this is the condition of tea gardens. See, this poor maintenance because they are not getting good returns. So most of the owners of the tea gardens, they are leaving this tea gardens and as you living this way without maintenance. People they go to this inside forest to collect this tree logs or these branches of the trees for their firewood, and regularly they use this road, and this area has been barren, and when the rain drop will fall on this area it will form a small valley, and after that landslide event. And you know Ambutia landslide, this is 1968. This took place in 1968 and very huge area of this was 2.06 square kilometer of the slide face. It was a funnel shaped slide. And after that, Professor Lesjak Starkel, he and Professor S.R. Basu from Calcutta University, they prepared up to 2000. And after that, me and Professor Basu took over and we done up to 2009. And then we met, at that time we met Mr. Subhash Gising also. He was a very good fellow and he asked for some suggestion for this mitigation. But that time the government engineers, they estimated about more than 10 crore rupees will be required to stabilize this one. So we suggested that leave it as it is and evacuate the settlements from the top area. So we are happy this was the landslide area. So now we have seen in 2011, after that I couldn't go there. And these areas have been stabilized without taking any necessary measures because automatically the bush cover comes out and they stabilizes the angle of repose and the amount of surface flow is also controlled. So hopefully by another 10-12 years, the whole slide surface will be stabilized if another devastating event does not take place. And lastly, it is urban agglomeration. This government has constructed this building to rehabilitate these roadside hawkers. Many of you have gone to Darjeeling Himalaya. You have seen that if you come down from Darjeeling Mall area to the bus stand or motor stand area, you will find that thousands of hawkers are sitting along the roadside. And the government has taken initiative to rehabilitate them here. They occupied the building, but they remained along the roadside and they use as their residential house. So this is the most pathetic scene in our country, in most of the developing countries, not only in India. And see the density of building in Darjeeling Himalayas. Now the vegetation cover is almost lost in Darjeeling town. I will show this diagram. It's an old diagram taken from Professor Basu, that the population is increasing here since 1800 and built up area is also increasing. So to increase this built up area, you need to delete this forest cover, and this is just just a symbol of deforestation in Darjeeling Himalaya. So nowadays, if you go there in Darjeeling town, apart from Mahakal Pahad and some extra areas, hillside areas, you will hardly find any vegetation cover. So these were this triggering factors. One is rainfall, I have shown, one is earthquake, and the other one is human activities. Now, some of the reasons are this is called inherent causes. Number one, it is geology. This is the geological map. And you know, main boundary fault and main boundary thrust, they have divided this one from Shivalik to Middle Himalaya, another one is from this middle Himalaya to higher greater Himalaya. So, and this is the thick coal seam, this is the tectonic boundary zone also. So here you will find MBT, main boundary thrust, and the lithology, if we see, this Archaea means is very old. It is Precambrian period. So it is about 450 to 460 million years before rock you will find in Darjeeling Himalaya. But they are forming the base bedrock. And from that time till today, alluvium deposits are taking place in most of the areas. These are the Darjeeling niche formation, of course, but they are composed of this mica schist and quartzite and purple slate in as a band in many places. So anyway, most part of the Darjeeling Himalaya is almost stable because they are harder than any type of rock. But where there is human intervention, slope has become module. In those places, in urban areas mostly, the landslides are taking place in a huge number. So after that, this lower Gondwana, this is Indian classification, Damoda, then Nahan group, all these things. And in most of the case, this Damoda series is the series which is carrying out this coal seams. Semi-anthracitic, this was determined by the ER mallet, but after that it is found that anthracitic coals. And if we see the number of landslides, phyllites, we know very well that this is very fragile rock. Then schist is also very fragile, and the number of landslides are the highest along this in this group of rocks. Now, if we see as a layman, if we take a mug of sand and if we pour it on the surface, we'll find that 34-degree angle is produced. But all the hill slopes are not formed of this type of loose sands. So in that case, the angle we have considered in landslide science, 40 to 42 degree is the stable angle, below which it is stable, above which it is unstable. So if we see the Darjeeling Himalayan situation, see in very few places the angle is very high, but these are densely said this vegetation cover, but some of the landslides are of course taking place in this side I have shown in the diagram. And from 24 to 42-degree slope is covering the highest part of Darjeeling Himalaya, and majority of the landslides are taking place in this group. So while the landslides are taking place, either the slope is more or the slope is moduled due to human activities to construct roads, buildings, and all these things. And these are alluvium deposits of course less slope in Shivalik Himalaya. This is Shivalik part. See nowadays, if we see from this map, this yellow are agricultural land. If you see the map of 1817, that time 89% of Darjeeling Himalaya was covered with vegetation, different types of forest. But nowadays, if you see, as a whole, Darjeeling Himalaya is covered more than 36% of vegetation cover. So due to this red are the human settlements, this is not new to you also. You are involved in this type of preparing maps. So these areas have been deforested heavily. So due to this, different types of problems are taking place. This is vegetation cover. Of course, it is one of the most important inherent cause of occurring landslide. Now, there are several other factors also here due to the constant of time, because I have to cover many things. I have reduced this one because drainage density is also one of the factors. Subsurface water, this is a runoff, it is one of the factors. Surface runoff is one of the factors. We can calculate many things. So after this, so we have discussed triggering factors and inherent causes. There are several other inherent causes also. It differs from one area to another. Now it is our duty. This part is our duty. Firstly, we'll have to prepare database and geotechnical investigation. Now see I have that book which was published by the GSI, Geological Survey of India. It is under Ministry of Earth Sciences. And they have published, this is the book, Inventory of Landslides of Northwest Himalaya. Some of them Northeastern Himalaya is also given. And they have prepared this inventory, one landslide in one line. Bus, it is finished. Nowadays, if you see, there are, of course, they are doing some of the works I will show here. I have already, this GSI has started one portal in which they are showing this different types of hazard donation maps. Some of the databases individual can also incorporate because of our long discussion in different seminars like you. And there are some of the people, now this earthquake magnitude has taken over by the OP Sharma. And he several times he came to this Shillong. And I told him that when you are in Ministry of Earth Sciences, why don't you upgrade this site like Italy? Italy, this landslide site is called IFFI. If you see a layman can see all the databases, maps, everything. So they have initiated this process. This is a good sign for India also. So this is the inventory, published inventory. But inventory should include the factors in stability of slope, all these parameters, attributes of soil, morphology of the slide slopes, all these things, this should include. This is geotechnical investigation. And these are the maps. This is very old. I have prepared by my own hand without any computer. At that time, we didn't have any computer. This is Mirik landslide. Just for example, I wanted to show this one. So we have done this survey with this ABNI level, use a small instrument we used to carry this one. This is the geological map of this Mirik landslide. This is the slide face area. And these are the micro slopes of this one. And after that break of slope means angle of repose had been formed. And the causes I will tell afterwards. And this is the contour map at 2 meter interval we have prepared through that instrument only. And this is the landslide phase. Now what happened? One chute means small streams. Two chutes from two sides are coming. And they have this percolated downside, suddenly it is vanished. And it was carrying this huge amount of water during monsoon period. And the water was coming out from the middle part of this slope. So regularly when this water is coming out from the middle part of the slope, then naturally the lower layer or the subsurface layer of that area will be wet, and the upper layer becomes a burden to this lower layer. So by this way this is formed, and this slide was created, and it was in many days back. It was in 19, you see, this is I published in 2001, but this was in 1997 case. So now we need to collect the pre-slide condition, what was there. Many of this thing after the occurrence of the landslide, you cannot go there. But there are several sources of databases and satellite imageries, Google images, all these things we have. From that thing we can prepare some of the documents. Local interaction, we can get some database also. So on the basis of this, we'll have to prepare the pre-slide condition. And after the occurrence, we'll have to prepare this detailed database. Landslide, length of the scar, width of the scar, date of the scar, total area affected, how much materials are displaced. Because this material are very important, but how much amount of material are going down the river. And this affect the lower course of the river by sedimentation. Now processes primary responsible, modified slope, type of slide, special features, all these things we need to include in this geotechnical investigation database. And after that, post-slide impact. After the occurrence of landslide, what was the impact of that area? Here, the road link between Mirik and the hospital had been disrupted. If it occurs in Tripura, the road link between the mainland and the Tripura is disrupted, and the whole state economy will be stopped, will be stagnant. So these type of database we need to prepare. After that, if you have any this technique, you need to prepare this block diagram on the basis of this. From this, whatever I told you can understand very well. This is the geological beds. It is formed of granite gneiss. After this talus material, and then these tubes were meeting and it was coming out. So this is not taking much time. Now here soil parameters. That time we used to use the Karshiang Tea Research Laboratory. It was in Karshiang. We used to carry the soil samples and they used to take. They had two conditions. Either they will keep this database with them, otherwise you will have to pay. So we allowed them to keep this database because we are getting free of cost. After that, after testing in most of the slide faces, we have found sand coverage is very high. This is apex part. We need to take in at different depths. This is in centimeter. So up to about 1 meter, 80 centimeters means 0.8 meter from the surface layer we have gone down, and most of them are sandy layers. So it is very porous layer. So water can percolate downside. So when it is occurring in many places, not all of course, Then the lower layer is formed with this, here it is very less amount of clay. So clay is formed in the downside. So naturally water holding capacity downside will be very less. You see in the top layer, water holding capacity in most of the cases, it is about 50. So in that case, this water in most of the cases, not all, I told you, it is percolating downside and creating subsurface flow. And this is creating further problem. So these are the databases we need to prepare detail for individual landslide if it is possible, because we'll have to appoint many people for this one. Every university, every institute, every organization, they will have to take initiative for this one. Now, hazard and susceptibility analysis. This is the most popular way of analyzing landslide, because if we propose the government, how can you take this measure for stabilizing these areas? So these are the hazard and susceptibility analysis. This is the most popular way since 1971 in the world. And since 1991, India is also this initiated different types of quantitative techniques of both hazard and susceptibility. Now, sometimes we confuse, if we consider the scientific point of view, what is the difference between susceptibility and hazard? Terminologically, landslide susceptibility definitions means to categorize the land surface into areas and to arrange them according to the degree of vulnerability of different causative factors. So this is exclusively spatial. For example, we are preparing different layers: slope layer, drainage density layer, then this lithological layer. So all these layers we are preparing related to the landslide susceptibility. After that, we are superimposing all the layers and we are preparing the total map, which is showing the vulnerability of the susceptibility of the areas spatially. Which area is much more susceptible, which area is less. There is an international scale, of course. Now, when the susceptibility zones further rearranged into different zones, according to the degree of actual or potential hazard from landslides, it means the temporal data we need to collect. For Darjeeling, Himalaya, we have collected those temporal data and we have plotted on the map. After that, we have rectified this boundary. So by this way, we can prepare hazard zones. So hazard is spatio-temporal. So scientifically, from landslide science, once in 1984, he suggested this one. Now in India, I am not going to I have deleted some slides for abroad also. If we see the history, this Pachauri and Pont in 1992, they have published one article in Engineering Geology. This was this MS dissertation of Pont from IIT Roorkee. And you know, this Pont is Manoj Pont. He is now one of the most powerful secretary in West Bengal. He is our friend. He has done PhD in our subject from Calcutta University. So he was a gold medalist, and on the basis of this quantitative technique for the first time in India. And this is A.K. Pachauri. He was a supervisor, Ashok Pachauri. After that, many people came. Ambalangan in DST, you know, Harsh Gupta, you know, Jagannathan, you know, many people has come forward on the basis of this formula. Some of them have modified, some of them have proposed something. By this way, when individuals have started to publish, then our Indian, this brand, BIS, Bureau of Indian Standards, they have formed a committee taking different experts from different fields. For example, this from university level, they have taken somebody. From GSI, they have taken somebody. From this Ministry of Earth Sciences, they have taken somebody. From scholar part, we were that in that committee also, and the leader was Professor S.K. Tandon. So after that, they have prepared this Bureau of Indian Standards in 1998. They have prepared this Indian standard technique and rating and weightage values. So on the basis of this, so for individual, if we consider for us, it is very difficult to use this technique at and on large scale basis, individual slope basis, because we do not have that much amount of money and that much amount of manpower. So that is why in some cases we have modified. This is thrust. This can be drawn from the secondary source, lithological formation from GSI map or ONGC map we can do. Lineament also secondary source. Tea garden also we can this draw from secondary source. After that we need to rectify from the field. Then settlement, relative relief, slope, then road, drainage, aspect, these 10 parameters. Initially, BIS proposed for 13 parameters, but some of the parameters are not valid in Darjeeling. That is why we have reduced. So after that, if you this multiply with the weight is and rating of individual parameters and add them up, you are getting landslide susceptibility value LSV. This should be V. On the basis of this LSV, we can prepare landslide hazard susceptibility zonation map. And I will show an example from Karshan subdivision. This was prepared by one of my research scholars. Now she is in Japan. And this Karshan subdivision, his name is Mili Jamatia. I will show after. So we have demarcated in most of the places we could not go. So then we hired the local people because they are very much acquainted to penetrate here and there. So we have given this GPS, handheld GPS, and told them by this way you record this thing and come back. After that, we have plotted in. Usually we had this Geomatica software. That time it was 9.1 version. So we have plotted this GPS reading on this one. These are the active landslides. So on the basis of this is a dam on which the active landslides are plotted. Now these are the different layers. This is lithology layer. We'll have to identify what the number of landslides are more or less. This is thrust buffer. This is relative relief and slope. So we have to count the number of landslide. If possible, landslide frequency will be more effective. Drainage density and lineament buffer. Slope aspect, this is very important. Slope direction. If we consider this part, you see north, northeast and eastern part. North, northeast and eastern part are this suffering from huge number of landslides in this case. Why it is so? Because monsoon wind comes from the southwestern part, hits firstly in the northeastern part of Meghalaya plateau. After that, it takes the route of the Himalayan foothill zone and hits this area. So this area is suffering from less number of landslides, and eastern, northeastern, all these parts are suffering from more number of landslides. Then settlement density and then road buffer. And after that, we have superimposed all those layers, and we have seen the database from the algorithm library in the software. And after superimposing them, we have found these are the active landslides in white mark. And these are the landslide hazard zones, where this blue is very high, then high, moderate, low, susceptibility zones. This is not, of course, a hazard. This is susceptibility zone. We didn't plot the temporal database, only 1 year data we have plotted this one. Low and very low. Now, after that, we have tested it, and we have found that moderate category of susceptibility zones are possessing highest number of landslides. So some mistakes committed because this our BIS proposed that it should be this tested for each this slope units, each micro slope units. So if we consider one whole slope of a hill and this micro slope units, if we need to consider, it will take long time because we do not have that much amount of money. You can do with this high resolution data, almost real time, you can get it. And if you prepare this one, this will be a genuine work from your side, of course, because there is hardly any large scale susceptibility or hazard zonation map till today, or at last till today in India. Only GSI has prepared this geomorphic hazard zones map, big wall map. After that, there is hardly any printed copy of the individual hazard zones. But this will be a good atlas if you take initiative. Lastly, it is risk zonation. This is very important. And risk is not an easy task today, although the term seems very easy, but it is not so easy to do. Say this is from Tripura. I will show this one. This is CTFB, Chittagong to Tripura Fold Belt. This is Bengal Basin. And you know the plate, this Indian subcontinental plate is moving towards its north and northeast. and this sedimentary layers have been folded because of the subduction zone of this Indian subcontinental plate to this Burmese plate. This is a moderate plate, but as a whole, this is called Central Asian plate. All this Eurasia, then Burmese, all these are included in this one. And this is Meghalaya plateau, which is very old. During Archean period, this Gondwana land, it is formed in southern hemisphere now. This is a part of this Gondwana land, and it is Precambrian deposit. So anyway, this way, and Darjeeling was here only. So this way, one of my scholars, Dr. Kopil Ghosh, has done work on this. I had a UGC project also. He's teaching in West Bengal Women's University now in Diamond Harbour. Now, these are the ridges and valleys. This is Boromura, Atharmula, all these continuous lines, almost dotted continuous lines are hill ranges, and these are the river valleys or the synclines. And it was all right. In the northern part of Tripura, it was a plain land, almost plain. But this eastern, then middle part is covered with these hill ranges. And I do not know what was the intention. The road was constructed across the hills. I will show afterwards. So this is the details. And if we see, this is the hills. This is Atharmura, this is Boromura, this is Atharmura, and these are the river valleys in Tripura. Now, when we are going to assess the risk, there are different approaches. We have considered this fuzzy set approach in this case. It is most important aspect of fuzzy logic-based analysis of the fuzzy membership values, and all these things we will see. And the steps are, firstly, we'll have to prepare susceptibility zone, resource potential map. Then we'll have to do pairwise comparison, this analytical hierarchy process method, fuzzy membership for landslide susceptibility and resource potential map. I will show afterwards. Then risk scoring we'll have to do, risk scoring for resource damage potential also we'll have to do. Then we'll have to multiply this landslide potential and resource damage potential to get this landslide risk assessment matrix, and after that we can prepare the landslide risk assessment map. Now we'll see, this is already shown. These are the layers of different lithology, road buffer, slope, relief. All these things are done. And after that, after superimposing, we have prepared this map, and this is almost matching with the reality, because instead of numbers, we have considered incidents per square kilometer. And you see this very high landslide susceptibility zone is possessing highest number of landslides incidences. So these are the landslide events, and along the road mostly. This is due to human intervention because the slope is moderate here. Land use, land cover value. So all these types, the area we have calculated, and after that we have assigned these rating values on the basis of aging factors in fuzzy membership. So this is a matrix, very high, moderate. Here it is also like that. One is landslide susceptibility, this value, this landslide susceptibility zones. And here it is this damage potential zone. And this is this pairwise damage potential 1, 2, 3, 4. On the basis of this matrix, we have prepared this table. This is landslide susceptibility, this is damage potential, and these red marks are the highest risk in these areas. So after that, this final risk assessment we have done, and this is landslide risk zones, and within which this LS1, LS2, LS3, all these things are falling. We have given some example here only. There are several others also. Now this is number of pixels in different resource categories for validation. So if we take this less amount of area, the possibility of this every slope facet we need to consider, then and only then it will come correct. And lastly, it is planning for protective measures. I will take only 5-6 minutes more. This is also from Tripura side also. Landslide, we need to collect the database for managing consequence, remedial measures and removal consequences. Firstly, we need to prepare landslide prone areas. This is susceptibility. Then database of landslide details, assessment of individual slope. Then landslide controlling measure. Then shape up the movement, which areas. Landslide notification, we know we need to give warning, but only for specific slopes, not all the slopes. If we start to give all the slopes, the people of the locality will be panicking. So we have taken this under that project, we have taken this individual slope for this study. And you know, from in our country, in most of the cases, the way of functioning, just I will show, we have prepared this, that time we got this total station. Then we have prepared this contour map with the total station. This is a terrain model of that area. These are the individual facets of the slopes. So in this slope, just say how many facets are there. Now, if we go to collect the data of all these individual facets, how much time it will take, just imagine. This is BIS proposal. See, I told you this our departmental activities, most of the this government departmental activities, it was sanctioned. The government has sanctioned the money for constructing retention wall, but they have constructed without any scientific investigation. See here, do you find any here any cement? Maybe only this cement and mud, this sand and mud, they have mixed it. Without any cement, they have arranged this way along the slope. And after that tar tins they have plotted, and when we have found that, then many newspaper clippings have started to come. They have constructed this thing only giving one poor hole along this retention wall, and this height of this retention wall cannot save. If any vehicle is coming and slope fails, they cannot save these vehicles from the landslide events. So now this is the way along the roadside, this type of water is seeping somewhere it is flowing. And these are the tar tins they have set to protect the slope from the landslide events. This is called geonetting with the tar tins. Now, my scholar and us taken this initiative to study the slope totally and accurately. All individual slope breaks, these are called the individual slope facets and slope buffers we have measured from the field. And then we have prepared this slope map, and we have proposed that this is the road, and here is the valley. There should be a gap between the road and the main slope. After that, we need to prepare this retention wall, and we have given the specification of the retention wall also. So when we are going to propose, not commonly will suggest something that this should be done, that should be done. This is not the way. Do this, we'll have to supply the scientific material for taking the necessary measure for the individual slope. Now, these are the grain size analysis of the soil samples collected from the different segments of the soil. Stay in different segments, the number of slopes and number of segments are there. Now, after that, we have this tested the materials in the laboratory lithology. This is secondary source. Soil type, we have taken it from this Indian Society, ICAR. They have detailed soil map, which is written by M. Datta of northeastern India. Then slope plane measured from the field, slope gradient measured from the field. So on this way, then we have proposed along this slope, the drainage. See, usually drainage configuration means we need to calculate surface drainage and both subsurface drainage to reduce the fatality from the landslides. Now, if we go to this Tripura, this slope one will show this drainage, how we have proposed. This is the slope. This is the retention wall. It should be at least 4 meters high from the base level. After that, there should be a channel between the road, white space, and then at the bottom of the slope, just immediately after a retention wall, so that when the water will come, at least vertically three pore holes should be there, so that the material, small sediment or water, if it comes, it can come down this stream and subsurface drainage and it can carry down to this river. So naturally, this is in our National Highway 44. This is the main trunk road which is connecting Tripura with the rest part of the India. We have proposed that at least 8-meter gap should be there, because if this slope fails, and if it crosses this retention wall, it can be deposited here so that the road remains intact. So by this way, we have prepared these details of this individual slope, and whole Ambasha area. This way we have done this. And by this way, with this individual slopes, we have proposed in different places, different height of the retention wall should be constructed. Here it is 15 meter, here it is 6 meter, here it is length is 54 meter this way. So by this way, we have prepared the report and proposed that if we can prepare this, we can construct this retention wall on the basis of this scientific investigation, the fatality from the landslide can be reduced. After that, we proposed another thing. This is the existing highway, national highway, and it is going this way. This is the plain area where we have hardly any expenditure, although this is very close to the border, but there are 3-tier security now in Tripura. So this is the existing road, national highway. If you come by road, you will have to come to this one from Assam to Choraibari, from Choraibari, then this this Ambasha, then Manu, all these things, then Atharmura, Boromura, you will have to cross, then you will reach to Agartala. But this is across the hills. We propose an alternative way. There is already a road. This is called bypass. The bypass is not so wide. So we have proposed that these are the landslide affected spots. And we propose that this should be the feeder roads. And this road should be widened and should consider as the NH 44 instead this one. So the amount of expenditure will also be less. Amount of landslide fatality will also be less. So by this way we can propose the necessary measure to the competent authority. Now vegetal treatment. This is one of the most important, NIDM and NDMA, National Disaster Management Authority, and National Institute of Disaster Management. Now they are disseminating the biotechniques of landslide protection, and these bioengineering techniques are very important in some cases because they are also giving the free supply of the vetiver grass, those who want from them to secure their surrounding land area, hill slope areas. And this grass can grow if you treat them properly. This grass can grow within 15 days, and very soon it will cover the whole surface of the slope, so that the surface runoff will be monitored, as well as this landslide fatality or landslide event will also be less. Moreover, this grass has a market value, because this from this grass the type of perfume is produced from this one, so it is a very high market value, and in South India it is now producing in this large scale. So anyway, we'll see. This is a slope, this is a testing slope. This slope is barren without any vegetation, and this slope is composed of grass cover. This grass cover has been planted along with this geonetting. This is geonetting, not wire netting. So after 1 year, we have found that this area is less affected by rock falls, and this area till now it is continuing the rock falls in this slope. So vegetation cover can create a stability of the slope by which the fatality from landslides can be reduced. So with this, we need the warning system. Firstly, historical database we need, along with geotechnical investigation. We need rainfall data, and we need to correlate with this rainfall. If we get earthquake data, NGRI supplying this earthquake data nowadays, so we need to correlate with this one, so that if any amount of rainfall takes place along any unstable slope, we can predict clearly that this slope is unstable, evacuate immediately from that slope. Now, antecedent and predicted rainfall, IMD is also doing very good work now. This we can get the data from that side, then current rainfall, and if we can superimpose all these things to correlate to all these things, then we can create, we can predict the exactly when landslide is likely to occur, and we can issue the warnings and notification. In some cases, it is started. About 10-12 years back, there was hardly any notification through media about the landslides, but nowadays sometimes it is being given. So these are some of the photos taken from different sources. Dhashe pore stabdo jatiyo sorok. So these are the ways we can disseminate the information related to landslide. So to minimize the injury and loss. So acknowledgement, this is Mili Jamatia, she is my first research scholar who done work on Karshiang subdivision. Now she is in Japan. And Dr. Kopil Ghosh, she done work on Tripura. And now he's teaching in West Bengal State University. Now on this issue, I have some suggestions to NATMO that you can prepare large-scale geomorphological map. There is an international list of symbols. I took training in 2002 under UNESCO, UNESCO fellowship, and I have that list. I can supply it to them, and on the basis of this existing topo sheet as well as your field verification, you can prepare large-scale geomorphological map. Or even if it is not possible large scale, at least topo sheet wise 1:50,000 scale we can produce. Number two, preparation of different layers. In order to different layers from that geomorphological vegetation cover, land use, land cover, in order to prepare different hazard risk donation maps. So this may be a very good atlas. Just we can try from one area. After that, we can proceed for this further. And at the end of that, atlas, we can include the database on temporal events. Although for individual landslide, it will take long time. At least some of the geotechnical investigations we can include with this one. So with this, I once again thank you, this director and all of my friends of NATMO and other participants. I'll be happy if you have any question, I'll be happy to reply. This is a landslide. See, we were in trouble. This is Jonggu Sikkim. It was occurred in 2016. And when we went there with two of my scholars, now one of my scholar, then the media people caught us that whether this landslide dam should be breached or not. Then whether we'll say yes or no, we are in this dilemma. So below this, there are 3 tiers of Tista barrage dams. Anyway, if we get any time else, we'll discuss this issue again. So with these words, I once again thank you very much for your kind attention.
Thank you, Professor De. You have pointed out many important aspects of landslides. It was a wonderful discussion. Now all the participants are requested to put on their video, and we will start our interactive session. I would request our director, Dr. Banerjee, to begin this interactive session.
Thank you, Madhurima. Really excellent deliberation by Professor De regarding this landslide, geomorphology, and other slope and other aspects while preparing the landslide zonation maps and different other related issues. He has excellent way he has described. Actually, I was also very much interested to have this geomorphological map of India because while working in ICAR, I found there that it was a very much required for the research analysis, large-scale geomorphological map. And as you have suggested, that is really it is a need for the country to have this type of map. And the number of staff members are very less nowadays. So I need the help of the university students or scholars we can have this project on collaborative basis. So if you agree, like the geomorphologists like you from different corner of the country, if we can arrange, if you agree, we can arrange one webinar to initiate this type of work. I think it will be very helpful for all of us, for the country itself. So, we have a geographer in our institute, we have geologists. I think they will be more interesting to have this type of map, like a landslide zonation map, hazard zonation map, or landslide, identify the landslide prone area in the form of atlas. It's really interesting. So we can take that initiative for future work.
Yes, we
With
are
this,
ready
I
to
thank you
help
again.
always. Our
Okay.
helping hand will always be extended to NEHU.
Okay, so thank you so much. And, we can think on that line.
Yes, yes.
Anybody else is there who want to interact with Professor Day? Please come forward. We'll be happy to answer you.
Yes, yes, Professor Shunil De, I am Shagota speaking, one of your batchmate of Calcutta University, 1989-90.
Yeah, yeah.
So I have a specific question. Is there a way to measure how far a landslide occurred from a reference point?
From a reference point,
Yes.
I could not understand the question very well.
From a reference point means it is not always possible to calculate the distance. So is there any, from any reference point, is it possible? Is there any specific means methodology that you can measure the distance
Which distance?
from the reference point to the landslide? Because it is not also always possible to reach the place.
Say yes.
From the imagery or from the real-time imagery.
See, nowadays you have this long range, this without reflector total station. So if you can go to the close area of that area, close part of that area, we can do, of course, from the field I am talking. And
Yes.
from this, regularly the satellite imageries are not being taken. It is taken during this cloud-free sky usual. So if the landslide occurs now, and if the image is taken in last week of October, so we can get the location of the landslide accurately. If there is any high resolution data, we can prepare the maps from that also.
Okay, but most of the cases, it will be cloud covered because it is landslide and it's rainy, means rain and all these things are related. So we might not be getting a very clear picture. So
Yes, in that case, you'll have to go
how
to
to
field.
overcome this problem?
You can go to field to a close area from where you can take the reading.
Okay, so field verification is the only way.
See, landslide is a
process.
field activity, no? From
Yes.
secondary sources, we can prepare the layers, different layers of maps. But for detailed study, we need to go to field.
This is Arindam. I want to add one more thing to Dr. Sugata's part of question. That we also use the Sentinel-1 image, that is the radar images, which penetrates the cloud.
Means SAR imagery.
Yes, hard imagery. Yes.
Okay.
And also we can go with the UAV, means UAV is a laser scanning device attached to the UAVs.
Yes.
Better
Okay,
resolution.
thank you very much.
Thank you.
Yeah.
Yes.
Anybody else is there? We want to thank all the participants, all the staff members and officers of NATMO and DST, Dr. Biman Ghosh, Professor Sunil Kumar De, and of course our director, Madam Dr. Banerjee. This webinar will come to an end with our national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
I thank you all for the participants. This is the end of the series of this seminar session. Thank you all.